welcome everyone. Thank you for tuning into this talk session with Dr. Tarun Sukhani from the Center of Applied Data Science. Before we start, I would like to say a big thank you to Dr. Liana. Dr. Liana organizes this session with us so that all of you, the students, will be able to get more insights about how big data analytics works, how big data management works, and how it could help you in terms of building a better career for your future. So Dr. Liana could not join us today, and without further ado, let's get the session started. We will start with introduction to CADS, and I'm going to invite my colleague, Miss Sheena. So Sheena, are you here?
Yes. Hi, everyone.
Okay, Sheena, over to you.
Okay, thanks, Sukhian. All right, good evening, everyone. Hope you're having a very safe day, and it has been a fruitful day for everyone. Okay, let me just introduce myself before we start. I am Ashina. I am the Strategic Partnership Lead at the Center of Applied Data Science. I work with universities, government agencies, and organizations as well to bring how to bring value and how organization can start embarking on a data-driven journey. It can be via talents or even within the company itself. So this is what I do. I advocate this whole data-driven journey with companies and universities. All right. Okay. So let's start this session. As I go, CADS has several offerings, also very good for university students. So if you have any questions during my session, what you can do, you can put on the chat that Sukhian mentioned. If you want to know more about the programs that we are offering and you're interested to know about this, just put on the session, the chat session, and we will actually reply your queries. Okay. So hope we can help as much as we can today. Okay. Let's start. Okay. Who is the Center of Applied Data Science? Okay, we are an AI technology solution company that helps enterprise maximize potential business by becoming a data-driven organization through a data-literate workforce. It's important that I think for an organization to become data-driven, the talents in the organization play an important part. So the talents are you guys, the youths out there, and also the workforce out there. So this is our vision. Our vision is to future-proof the world by improving data literacy as an economy for the workforce. It's very important, especially in this day and age. All right. And the mission really is to accelerate the enterprise journey to become a data-driven organization by empowering the workforce to become data literate. It's again to do with talent and how talent needs to be data literate. It's a call, I think, for all talents out there. It's important to actually go and address your data literacy now. All right. Okay. So I just want to give you an understanding of what CADS and who was CADS and how we started, so you know how the journey of CADS has developed and what we have done with graduates and professionals out there. All right. So CADS was founded by Sharala Exrit. She is our founder and CEO, a Malaysian entrepreneur and a local graduate from UKM actually. All right, and she's got an engineering qualification and she worked abroad for many years in the telco industry. Okay, and she decided one day she needs to return to Malaysia. And when she came back to Malaysia, she was looking for talents in data-related roles, right? Because she was in the telco industry, and this is something she came back. She wanted to start a business, but it was so hard to come by these sort of talents. This was around in 2012, I think, if I'm not wrong. All right, so she couldn't come by these talents. So this actually inspired her journey to create these sort of talents for the country. It was important for her. She knew that this is something that Malaysia needs and she wanted to create these talents. All right. So our journey really started in 2014-15, where we partnered with Data Incubator. It's a leading data science incubator in the US. Okay. Through this partnership, what we did is we were able to offer data science accelerator programs to transform science and engineering students into qualified data scientists and data professionals, really. So because we couldn't come out and just start upskilling people just like that, so we had to franchise this program from Data Incubator, and we started training as many data professionals out there, working professionals. Okay, so as we grew, we also established a collaboration because we realized that companies out there, they need to realize, why is it the awareness, right? The advocacy, why companies need to be data driven. When companies become data driven, that's when talents also can get the jobs, right? So why is it important? So we needed to collaborate with known universities out there, known like Harvard University, to actually bring Harvard down to create the awareness to the C-levels from organizations, right? So what we did is we spoke to Harvard Business School, the executive program, education program, and they agreed to come and actually do this advocacy, a program, a 4-day program that we structured together with Harvard to come and deliver here in Malaysia for 4 days. And actually, when during this time, I mean, even now, Harvard Business School does not conduct any program outside its Boston campus. But Harvard was agreeable to do this for the country because we were looking at it. We were working with MDEC at that time as well. All right, so this is the advocacy we started, and we by 2017 we managed to train and upskill over 2,000 data professionals. All right, working professionals, and we also have a program where we work with graduates, which I will actually explain to you how the graduate program is called, our Data Star program. It's our trademark program, actually, Data Star, and I will explain to you how that works later on in our slides, okay? So along the way, as we were training, now if you are a talent, you are a graduate, if you want to come and take a program with us, it's so important that these programs needs to be accredited, right? You don't want to come and take any programs out there. So we know this is important, so we have actually accredited our whatever offerings that we are doing. We are offering the market with AICB. This is for all the banks. MBOT, Malaysian Board of Technology, recognizes our programs for the CPD accreditation. And Informs is basically association, right? It's a well-established professional body in the US where it's recognized globally. So all our programs now are recognized by Informs, and if you are taking the programs, you can actually continue your journey to become a certified analytic professional with a title, and you start off as associate CAP and you can become a CAP. This is with the working experience. So this we have done in globally, and locally is MBOT that's accrediting the programs. Okay, so we have done this, and then along the way we realized that 2020, what's next with this pandemic and everything? We want this whole ecosystem to come together, because I think we need to have the support for talents, the industry that we work with, the job roles out there, what sort of matching job roles is there. So we came up, we'll be launching this platform called CADS AI platform, which I'll explain to you a little bit later. So it's a sustainable ecosystem, basically, where there'll be workforce transformation happening, and it's a vibrant data professional platform. Okay, so this is a little bit about CADS, okay? And just for information, we are present now, our headquarters in Singapore, based in Singapore. We are in KL, of course, and we have our presence in Thailand, Philippines, Vietnam, and Indonesia. All right, ASEAN is a target because ASEAN is a market now that even you as a talent can go and approach, because now jobs are borderless. You can actually reach out to all these in this region and actually work for any of these countries. So the CADS AI platform is about this ASEAN presence that we are working with in an ecosystem. All right. If you have any questions, please put on the chat box and we will try to help you. Okay, so what are our offerings, right? So as I mentioned, I repeated to you on the CADS AI technology solution platform. So this is a vibrant data professional community platform where what we are doing here is a digital workforce transformation platform for individuals and companies to explore. So for companies, we have the Celtic Enterprise Solution platform, where they come in, they actually register the job opportunities available. And there's a lot of features in here, which I'll show you later in the next slide, what the Celtic can offer. But for students, you have the Rubik Data Professional Network platform, where you can actually register, you can actually do an assessment of what sort of data literate skills you have. It can be very basic or it can be very advanced, depending. And we will give you, the platform will offer you skill gap analysis of what sort of skills you have and what sort of skills you need to have to become a data professional. And this will be like a job portal. It works as a job portal where it also will link you up to all the job offerings which is there out there. All right. This is an interesting platform that we are launching in end of June, July. All right. Okay. So apart from this, this is the learning pathways that we actually offer at the Center of Applied Data Science for you to become, you can start your journey to become a data scientist, a data analyst, or a data engineer. All right. So our programs start from really entry-level programs. That's called the Enterprise Data Practitioner Program, where you don't need to have any sort of technical skills, even coming from a business background or from even accountancy background or whatever, you can actually start your journey to become a data professional. So here we cover program modules such as Excel analytics, data storytelling. These are the core programs that we cover here. It is very entry level, which you can actually explore. And then the next level is called the beginner level program, where we start introducing you to programming skills, Python skills, and all that. So it's a step-by-step approach to become a data professional. So this is something when you go onto our Rubik platform, you'll be able to, we'll assess you, the platform assesses you and recommends to you which track that you need to take, which sort of skills that you need, all right? And it will come from here or even our other learning partners, all right? So this is our learning tracks. If you want more details, we can share that with you, or it's also in our website, all right? And this is the one interesting program that when I mentioned our Data Star trademark program, which comes with scholarships. The fresh graduates completing, you are a graduate coming from PhD or just qualified into a program, you can actually apply for Data Star program. It's actually a fast track data professional program which caters for 2 months intensive data science enablement training and mentorship. After you qualify, what we do is we place you in the industry. We help place you in the industry. So we have sponsors for this program, and of course, terms and condition applies for you to apply for this program. Okay, so this is the CADS AI ecosystem that I was talking to you about, where you have all the enterprises, the companies, the organization posting jobs here, all right? And of course, we support organizations as well with their skill, the data-driven journey, all that for the internal development, and jobs are posted here. These are individuals, where individuals will also come onto the platform. It's an ecosystem, all right, where everyone supports each other. And here, individuals like yourself, you come in, you actually do an assessment, you do a CADS skill assessment to see what sort of skill gaps you have, and it will be matched to the job availability outside, the projects or any jobs that's related to your skills. And you can also have an opportunity to have a certification taken up, okay? And this is where I mentioned that we will propose learning paths to you depending on your skill gaps that you have, all right? So it all happens in this vibrant data ecosystem professional platform that we are having. And of course, we can't do that alone. CADS is not only the provider that will be in the platform, because we do a lot of online instructor-led programs. We are going to have other partners such as LinkedIn, Coursera, and everyone else onto this platform, where when individuals come onto this platform, like you yourself, you can have the opportunity to explore different learning partners that are offering these sorts of learning programs for you, data science programs or data professional programs, okay? All right, so this is our whole CADS AI ecosystem. All right. Okay, and these are the different partners which I was talking to you about. CADS is one, CADS Academy, that's our programs. Then we will be having Udemy in that platform. LinkedIn also will be there, Coursera, CloudSuite. So we are talking to all these partners now, and they are going to be onboarded into this platform. And you have the opportunity to explore this sort of certification on the platform. All right. So yeah, that's about it. Okay, this is the Data Star program that I was talking to you about, one of our core trademark programs offering, where graduates like yourself, after you graduate, you have to complete your graduation, right? You can apply for our Data Star scholarship. And we have sponsors. We work with Peneraju, we work with MTDC, a few other sponsors, where you come into the program, you upskill for 1 to 3 months, as either you get into a track as a data analyst or a junior data scientist or a data engineer. Up upon the assessment that we do with you, we will put you into the tracks. You graduate, then you go through a placement with our industry. And we also place you 12 months with companies. It's a contract, 12 months employment with a company. We will source this for you, for companies. And the starting salary, graduates, for this Data Star, it's as low as 3,000 is your minimum. And you can go up as high as 5,000, depending on the company offering this program. So our normal range, they start at 3,500 actually, and you can go up to 5,000. And we have graduates offered jobs at Singapore and all that. So it's quite a in-demand program that people are looking for. Companies are looking for these sorts of graduates now. Okay, so that's about it. Sukhian, you can take over.
We will continue with the session with Dr. Tarun for now, where Dr. Tarun will be talking to you and giving you insights about how can we create business value with big data management. So Dr. Tarun, are you available right now?
Can you hear me?
Yep, I can hear Dr. Tarun. Anyone, any issue with your mic? Can you hear Dr. Tarun? Please type on the chat so that we get to know. All right. Yep. Sheena can hear, right? Okay.
Okay.
Right.
Thank you so much. Yeah. Thank you everyone for attending. Thank you to the organizers, University of Malaya and CADS. So yeah, my name is Tarun Sukhani. I'm a principal data scientist at CADS. This is a little bit about me, my profile. Basically, I'm a business and IT professional with over 25 years of experience now. I think I've pretty much done all of IT in my career. And then, of course, I've been teaching for over 15 years now. Next slide. So the agenda for today is we're going to be talking about big data management. So we'll do an introduction to big data. We'll talk about what is, big data management. We'll talk about some of the components of big data, like serverless computing, ETL, ELT, and then we'll go through some use cases, and then I guess we'll end with a case study. Okay, so let's cover the introduction to big data. I think we can play the video right away, right?
Class taught us about the Industrial Revolution, when steam power changed how things were manufactured. But there hasn't been just one industrial revolution. The manufacturing industry has reinvented itself many times. The first industrial revolution is the familiar one. Beginning in the late 18th century, manufacturers used steam engines and hydraulic power in factories to make production more efficient. The second revolution began in the late 19th century, when electricity and assembly lines made mass production possible. The third took off in the 60s, when advances in computing enabled us to program machines and networks. Today, we're at the beginning of a fourth industrial revolution. Industry 4.0 is about connecting the digital and physical worlds. Today, most manufacturers' key assets are a part of the physical world. The workers, machines, tools, and inventories that drive both the production process and the end product that customers use every day. But emerging technologies allow manufacturers to use data produced by these physical assets to drive insights based on data. These technologies will enable the construction of new solutions to some of the oldest and toughest challenges manufacturers face in growing and operating their businesses. Eliminating unplanned downtime in the factory. Ensuring you never start work on the production floor that can't be finished with the material, labor, and machines you have on hand. Tripling the leverage you get from costly support labor and specialized tech talent. Changing the dynamics of your channel and creating new sources of revenue. Enabling your products to sell services for you. Growing your data business as big as your product business. Using customer and channel connectivity to achieve unprecedented levels of customer service. And the changes for the industry as a whole will be even broader, as broad as we've seen in past revolutions. Industry 4.0 will change the basis of competition, alter how manufacturers win customers, shake up the structure of the manufacturing industry, and give you the opportunity to make history.
Yeah, so big data, and Industrial Revolution 4.0 or IR 4.0 are interrelated. Basically, IR4 is what is driving big data, right? So because of cyber physical systems, digitalization, digitization, we're basically producing, right, a lot more data, yeah? And not only are we producing a lot more data, right, but we're also producing data at volume, velocity, and variety, yeah? So it's not just the volume, it's also the different types of data. A lot of the data today that's being produced is, visual, auditory. It's basically a lot of non-textual data. And also the velocity of data because of IoT. So IR4, of course, made IoT very popular. So big data basically is a combination, right, of all of these technologies together, driving the need to manage all this data in an effective way, sometimes, in real time. So if we look at the evolution of big data, it really kind of grew starting in, 2005, 2006, right? Because that was when, Hadoop was open sourced, right? So Hadoop was basically the open source version of Google, okay? And Google had been doing distributed computing for a number of years up until that point. And so once Google kind of released a paper on their distributed system, a bunch of companies came in and created a business model around open source versions of Google's ecosystem. And so that's how we kind of got into the big data craze. And then, of course, it exploded after that. So starting in the 2010s, we had cloud computing, right? So cloud computing plus, distributed computing basically, drove big data in the enterprise. Okay, so companies started to, deliver these systems basically to, the cloud, and it basically had a life of its own at that point, right? Now, later on, of course, starting in 2015 to 2017, all of this stuff, became essentially coupled with machine learning, data science, deep learning, and a lot of these tools in data science were also open source. So if you combine open source distributed computing with open source data science, with, in some cases, even open source cloud computing, or at least, cheaper cloud computing, then effectively you have what we have today, okay? And so that's what we mean by big data. Okay, next slide. So there are what we call the 5 V's of big data. So I've talked about this already. I've talked about volume, variety, and velocity. The other 2 are veracity and value. So veracity is how reliable is our data, right? Is it coming from a reputable source? Can we rely on that data to produce models, machine learning models that are accurate and, have high precision recall and all this other stuff? That's the question, right? And then all of that together essentially delivers value. Yeah. So if we look at, what has happened with big data, in the last, 5-10 years, we've seen an explosion, right? And it doesn't really set, anywhere near to end. So it looks like this is going to keep on growing. Yeah. I mean, one thing that we can definitely say, however, is that there's definitely been a consolidation in the industry. So companies like, in the old days, in the early 2008, 2009, 2010, there was competition for open source distributed computing, So there were companies like, MapR, Hortonworks and stuff like that. But, eventually Cloudera kind of won out. And now pretty much it's all Cloudera, right? There's really no other competitor. So if we're talking about Hadoop or Spark, I think, which we'll talk about a little bit later, Cloudera is really the name of the game here. Yeah. Okay. So if we take a look at big data applications, right? There's a number of players within big data management, okay? So we essentially have data owners, we have data viewers, we have system orchestrators, and of course we have the big data application providers, okay? So these are, companies like Cloudera, okay? And so data owners essentially provide the data, right? We are basically dependent on these data providers, right? A lot of these data providers are providing, of course, second-party data that companies need in order to produce products and services, right? And of course, the data providers the data owners can also be internal people, right, within the company. And then, of course, you have the system orchestrators. These are the people, like data engineers and data scientists, all these people that work together to take the data from data providers and, of course, leveraging the frameworks in order to produce an end solution, right? So this end solution is what is consumed by data viewers. So it could be a machine learning model, it could be data, visualization or something like that, like Tableau, whatever. So this is the ecosystem that we're talking about, really, when we talk about big data, right? We're not just talking about big data frameworks. We're talking about, data producers, data consumers, and the people who make everything possible in between. Next slide. Okay, so there are a number of applications of big data, of course, in the industry today. One of the biggest applications is digital marketing. Of course, that's how Google made its money, right? Through essentially digital ad publishing, right? And then, of course, there's other applications. There's data exploration and discovery. There's fraud detection and prevention. Of course, this is a very big deal in BFSI, banking, financial service institutions, insurance, stuff like that. Social networks and relationship analysis. Of course, this is social media marketing and stuff like that. Machine-generated data analytics. So this is where IoT and all that stuff comes in, right? Machine learning, IoT, deep learning. And then, of course, we have the boring data archival, right? Storing data, right? So that's still, of course, very important. It's still a very important application. Next slide. So if we take a look at big data and business analytics in general, and how these two kind of work together, big data is all about, getting the data to the right people at the right time, right? At the right speed, et cetera, et cetera, et cetera. It's all about data management, right? And then analytics is about taking that data and then doing a value add, right? Producing models, predictive models, or producing visualizations that are actually useful to consumers. So we can see that, there's a lot of elements at play here. I'm not going to go through, obviously, all the different types of analytics, but I'm sure you can imagine that it applies in almost every major vertical, right? So telcos have their own type of analytics, right? Defense industry has their own type of analytics. Healthcare has their own type of analytics, so on and so forth. Next slide. Yeah. So if we look at big data sources, again, most of the big data sources today are coming from us, right, as consumers, within like e-commerce, for example, or just social networking. Another source, of course, is the cloud itself, right? All these applications running in the cloud, the web itself, IoT, and of course, even traditional databases and data warehouses still are a source, of course, of big data. Okay, we talked about, the providers, right? Actually, I should say the framework providers, right? And I mentioned Cloudera, right, as like the big one right now left over. So they provide a lot of these tools, okay? So here are some of the tools that you may see, yeah? So in terms of like, real-time processing, in terms of extracting data, we've got Scoop and Flume, right? In terms of real-time processing, we have Spark and Apache Storm. There's a bunch of other frameworks out there for real-time processing. Flink is another one. And then in terms of data storage, we've got Hadoop itself, HDFS, the Hadoop distributed file system, which is the one that was, modeled after Google's infrastructure. And then of course, we have many different types of NoSQL databases today. NoSQL became popular because of Google, right? And when Google published their paper on their own NoSQL database called Bigtable, that's when other people started to produce their own open source NoSQL databases like Cassandra and HBase. And there were many others. So all of this stuff kind of exploded, in the last 10 years or so. So, if you're a fresh graduate, whether you're undergrad or even master's, and you're entering this world, right, of big data, or just data management in general, you have to be aware of what's going on, right? So there's three things going on, right? There's real-time processing. A lot of it is driven by IoT, right? Time series and things like that. And then there's normal transaction management, right? And that includes also, if you want to talk about data warehousing and everything. And then there's also then predictive analytics, prescriptive analytics, and that's driven by, machine learning and deep learning and all that stuff. So there are three major areas that play within big data management, and you have a choice. You can choose where you want to specialize, okay? And of course, there's data visualization, right? That has always been there anyway. Okay, so next slide. So if we take a look at a big data architecture, just as an example, right? We have the data warehouse with its data marts and all that stuff. So that's called business intelligence. We have analytics, which is the machine learning models, right? We have the visualizations, right? Like in Tableau, for example, right? And we have all the infrastructure, the HDFS stuff, the distributed file system, all these NoSQL databases, right? So that's, those are the three things that are at play today, right? And then it just talks about networking, location, web, social media, customer provisioning, billing, et cetera, right? So these are all, things that you have to consider when you go into big data, right? There's a cost, of course, associated with maintaining this infrastructure. So, usually you're going to have larger companies implementing this, right? You're not going to have small companies implementing major infrastructure. So that's another thing you have to consider, right? When you enter the job market, right? Are you going to be working for larger companies that will require these type of larger infrastructures, or are you going to be working for small companies that may have a much smaller footprint of this, right? In terms of big data tooling, right, of course, there's the data storage and processing end of it, which is like Hadoop, for example. Then there's the data analysis portion of it. There's the data warehousing part of it. There's the NoSQL database part of it. There's the real-time processing, and there's messaging. For example, Apache Kafka is a popular messaging queue that's used, by large companies like LinkedIn. And I think we can watch this video, right?
Capgemini, we have developed a methodology in web architecture. The methodology starts, of course, with defining with you the right business process or the new business model. So to be sure that this project will be a success. Once we have defined use cases and we have chosen on which one we want to start, then to deliver it, we will use our big data reference architecture based on 5 main pillars. The first one is about identifying which data do we need, and not only that, but what we can do with that. So what are the legal constraints that are coming with that data? The second pillar is about acquire. How do we move that data to the right database, the right ways to store it? The third pillar is about marshalling and organizing the data. So once you have the data, you need to store it in the right way, and not only to store it, also to define it, to remodel it, to be sure that the data will be usable for answering to your use case. The fourth pillar is about analytics. Now you have data, we will create value from that data. So we will find new data models, you will compute KPIs. And the fifth one, it's about acting. Now I have this data, now I have the insights. How will I transform it in value, in business? It's about telling to your suppliers or your customers insights. This is the act part. And all that works on one foundation, which is based on all the data governance. You need to understand the data and to control it from the beginning up to the end of the process. It's important for you to understand that big data is not a change in terms of how we work. It is just a new set of tools that improve and allow you to do it better and sometimes cheaper than the way you were acting before. This is big data.
So basically, there are other aspects of data management, right? And this is Capgemini. Of course, Capgemini is, a very famous consulting company, blah, 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 And I think what he's raising is there are, in addition to just the infrastructure, and the so-called processes involved, right? The software and everything like that. There's also other elements. So we can talk about these other elements. So one of the biggest elements in data management, especially of course, including big data management, is data governance. Yeah. So data governance means who has access to the data and when and how, right? So of course, that's intimately tied to data security and privacy, right? So this is a major concern in today's world because of all the ransomware attacks and cracking and hacking and whatever terms they want to use nowadays, that's going on, right? There have been a number of high-profile ransomware attacks that have occurred, okay? And oh, by the way, if there are any questions, please do let me know because I may not see them, right? I think I see a question though.
Yeah, Dr. Tarun, one question from Sang actually. He asked, how can we differentiate data governance versus data provenance?
Yeah, so basically, data provenance is the same thing as data lineage, okay? Data lineage means where did your data come from originally and what transformations did it go through to end up in its current state? Okay, so that's called data provenance. Data governance is how do we control access to data at different points in its transformation? Data governance is about, you go on the board of directors and you're doing governance, right? So that it's like that, okay? And then you can see the rest, architecture, database systems, master data, metadata management, right? That stuff we've already talked about and pretty much know. But then there's quality control, right? Data quality is a big deal, okay? Especially if we're talking about big data because, if we come to rely on big data and let's say we have a lot of data, right? Or we have a lot of velocity of data, if something goes wrong, right? It could screw up our entire models. and give us very erroneous predictions, okay? This happens all the time in business. It happens all the time in science, right? There have been a number of false discoveries in astronomy and physics because, someone screwed up, quality control, right? So this is something we have to fiercely monitor, right? And it doesn't really get a lot of attention, but it really should, right? And then the rest of the stuff we know, right? Because we've talked about it already. Warehousing, transformation, integration is basically data integration, right? We have to combine data from different systems. Okay, so if we look at data management services, right? We're talking about, what are the things that are involved, right, in managing data? Okay, so there are a number of things that are involved. There's the operation side, right? There's the product safety side. There's the machine learning kind of, data science side, right? So there's many people working together, operations people, data science people, product safety people, etc. They're working together in order to deliver high quality data. Yeah.
Okay.
And I guess you get to pick and choose which one you want to belong to, right? So if you're very much a business oriented person, you want to go to the business side of it, right? If you're an infrastructure person, you want to go to the infrastructure side. If you're a computer science kind of person, then you want to go to the computer science, machine learning maybe side. Okay. So big data management is directly linked to the idea of managing the data lifecycle, also known as data lifecycle management. Okay. I'm sure a lot of you who have a background in computer science or software development have heard of ALM, right? Application Lifecycle Management, right? Sometimes it's also known as SDLC, right? Software Development Lifecycle. So data architecture and is completely separate from software development. Okay, so it has its own lifecycle. Okay, so we actually separate out data science from computer science, so to speak. In other words, we separate out software development from data management. Okay, so of course they work together in order to deliver a solution, but they're treated separately. They have their own managers. So for example, in a data architecture, we would have a chief data officer, right? Whereas in the software development side of IT, you would have a CIO or CTO. Yeah, so it's completely separate. So how does data lifecycle management work? This is the data lifecycle management basically. So we essentially have data collection, access, data usage, storage, transfer, and destruction. So it's kind of like you generate data, you use the data, you transform it, and then you dispose of it when it's no longer useful. Okay, what are some of the big data management challenges in today's world, right? So one of the challenges obviously is, leadership, yeah. Another challenge, is talent, technology, organizational culture. So all of these things, factor in, right, into challenges. Some of the other challenges, which I think a lot of people are familiar with in today's world, is data silos, right? Companies have departments. The departments don't really share information well, so it becomes siloed, right? And then we have growing data stores. We have data and architectural complexity. There's another challenge is ensuring data quality, inadequate staffing, lack of executive support, top-down support, establishing a data-friendly culture, right? So all of these things are challenges, right, that we all have to face. So, what are the benefits then of big data management, right? Why would you want to spend all this money on doing big data management, right? Well, the large companies obviously have shown us why, right? First of all, they make tons of money, okay? Not only do they make tons of money, but their profitability is through the roof, okay? They have better customer service, okay? They have better marketing. They have better efficiency. They have better cost savings, right? But they also are able to generate new applications that never existed before, right? They have improved accuracy for analytics. And of course, they have a huge, competitive advantage as a result. So what about the big data management practices? How can companies overcome massive data management issues and maximize their efforts? So there are several good procedures that have been recommended. So number one is involve team members from all of the relevant departments in your big data management efforts. So this is how we overcome, data silos. Create a written strategy and policies for data lifecycle management. So this is where we actually put SOPs and processes in place for DLM. Identify and protect sensitive data. Okay, this is data governance, also known as data governance. Deploy strong identity and access management. That's also data governance. Invest in training for employees. I guess that's talent management, upskilling, reskilling. Enable data sharing across your organization. Again, that's about breaking down silos. Consider appointing a chief data officer, right, which we just talked about. So these are some of the major functions within big data management. This is what people would be hired to do, right? So this is where you would find the jobs. So number one, data cleansing, data quality. Okay. We also call these people data stewards. Then there's data integration. These people are involved in systems integration. They combine different data sources and data sets together, okay? Creating new schemas, et cetera, like that. Data migration, moving from one environment to another, right? Or moving from on-prem to the cloud, et cetera, et cetera, et cetera. Data preparation, right? So data preparation is getting the data into the right format for analysis. So a lot of you who already are taking data science are already familiar with the fact that, machine learning models don't understand human language, right? You have to convert everything to numbers, right? We call that vectorization. And then of course, there's data enrichment, right? And data enrichment just means adding additional dimensions, adding additional, information, right, into the data so that it becomes more useful, okay? Basically, we're improving the raw data, yeah? The list goes on, of course. You can become a data scientist. So you could start off with data, becoming a data analyst, right? And then, moving up the hierarchy until you become a data scientist, right? We already talked about data quality, master data management. This is also known as MDM. You may see that term bandied about, MDM, right? So that just means, obviously, who is responsible for the single version of truth, right? Where do people go to get the master data, to get the single version of truth? A lot of that information could be, for example, in data marts, right? Data governance and ETL, right? So you can hire people who just specialize in ETL or ELT. ELT stands for extract, load, transform. ETL is extract, transform, load. So the difference between the two is in ELT, we extract into a temporary storage like Hadoop, and then we transform it and dump it into a permanent storage, okay? Next slide.
Big data is a natural fit for the cloud. Growing data volumes demand elastic environments and agility in deployment. So why isn't everyone doing it? Getting consistent performance from big data applications is hard if you're sharing services with other teams and organizations. And to maximize business value, you need to integrate all this new data with your existing data, applications, and reports. Oracle Big Data Cloud Service gives you high performance. And because you're not sharing hardware, performance is consistently high without sacrificing agility. And Oracle Big Data Cloud Service is the only cloud solution which gives you one fast SQL query over all your data, whether it's in Hadoop, NoSQL, or Oracle database. Your SQL skills still work. Your applications don't need to be rewritten, and your security policies still apply. Oracle Big Data Cloud Service gives you a complete big data environment, featuring Cloudera's distribution, including Apache Hadoop and Apache Spark. You get one-click provisioning, simple to deploy and easy to use, and a common console, easy to read and use. You can easily access the Big Data Cloud Service via SSH, VPN, or Direct Connect, your choice. There's easy ingest and export of data. Use Oracle Cloud Service both for backups and as a data lake. Query all your data with a single SQL statement using Big Data SQL. Analyze all your data using Oracle R, Big Data, Spatial, and Graph, or your own applications, which you can move to the cloud. Orchestrate your big data workflow.
I think we can stop because you know, we have to kind of continue on. We're kind of behind. So I just wanted to say that there's a lot of big data vendors, right? And it's basically broken down into three major areas. So one area is storage, right? That includes NoSQL, distributed file systems. The other types of companies are focused on data cleansing and ETL. And the other type, and the last type of companies are focused on analytics. So SAS, for example, SPSS are focused on analytics. Yeah, so for serverless computing, you know, basically that's another kind of technology in big data management. So serverless computing is the same thing as function as a service. So serverless computing just means, right, that you write functions that live in the cloud, and the functions get triggered. They run for, you know, a certain period of time, usually a very short period of time. They do something and then they disappear. They poof, you know, disappear into the ether. So basically, you get charged only for that period of time that that function lives, right, in memory. And so the advantage of serverless computing is that, you know, you don't have to have something running all the time in the background, consuming electricity, consuming money, right? It's essentially event-driven, okay? And there's a number of companies that offer serverless computing, cloud companies. So of course, the major ones will offer it, okay? So I guess we don't really need to discuss that. The top three will obviously have that. What are the applications of serverless computing? So, you know, if you're just talking about monolithic applications or microservices, they can all benefit from function as a service, also known as FaaS, right? So for example, a great example of function as a service, right, is sending notifications. You know, if something happens where your order is shipped, it calls the function sends you a push notification or whatever, and then it dies, you know? So that's a great example of function as a service. If we look at ETL, we have SQL and NoSQL. We have SAS, we have XML, we have a number of different, you know, databases, data sources. All we're doing is extracting the data, transforming it and loading it, and then we can put it into a data warehouse, do analytics, or we could do predictive models, right? What is the difference between ETL and ELT? We already talked about that, yeah? In big data, we mostly do ELT, okay? So we can see that in this diagram here, the difference between ETL and ELT, yeah? So we extract it, we load it, and then we transform it. So transformation is actually the last step, yeah? We're gonna skip ETL with Pentaho. Pentaho, by the way, is a big data vendor, okay? They provide a number of tools, right, for analytics and for storage, yeah? Including, of course, business intelligence, data warehousing, yeah? But of course, you know, they support the full big data stack. So if we take a look at Apache Airflow is also something that's new, that's been introduced into the big data ecosystem. And Apache Airflow has become really popular, okay? Apache Airflow basically is an orchestrator. It allows us to orchestrate our data extraction, you know, our cleansing, our transformation in a very simple way, right? Using something called DAGs, directed acyclic graphs, okay? And it's basically just a workflow, okay? So a lot of people, a lot of companies are using Airflow now to do all of their major data pipelines, getting the data from one area to another, also known as data migration, yeah? So data migration and data transformation has completely changed because of Apache Airflow. So these are some of the big data use cases, okay? So one use case is a 360-degree view of the customer. So this is part of digital marketing, right? Sales and marketing. So there's fraud prevention, right? That's another huge, I guess, use case for big data management. And then we have security intelligence, right? This is cybersecurity, right? Cybersecurity, yeah. Social media analysis and response, social media marketing, right? Dealing with big data coming from social media. IoT, right? Enterprises in every industry, of course, are using IoT. Everything is becoming IoT, right? Let's take a look at a case study. This is from Fave, okay? So Fave basically revolutionized their data warehouse. And they did on-the-fly transformations. I think we can click on that link. Yeah. So if you take a look at that, right, that's actually an article that was written by them, right, by the Fave engineering team, about how they transformed their data warehouse. So the problem was before their data warehouse was very slow, and it wasn't able to provide the information they needed, within obviously a desirable period of time, right? So this just goes through like what they did to transform their data warehouse, yeah? So I think we can go through it a bit, but not sure if we have time to go through the whole thing. So basically the problem was, we can read it. Our existing reporting data warehouse was aging, the strategy behind it unscalable, the problems ensuing from it untenable. Our revitalization was overdue. We wanted to be in a position where real-time reporting was available to support the business across 3 countries and potentially more countries in the future. So they really needed a data warehouse that was more responsive in real time, okay? So how did they achieve this, right? So the way they used to do it, right, was in the diagram there, where they had a production database, right? And they did normal ETL. They would copy the raw tables daily. It would take 4.5 hours into their reporting data warehouse, right? The so-called, the normal data warehouse. And then from there, they would run SQL scripted transformations. And that would take 10 hours. And so basically, you're talking about 14.5 hours to generate a report, right? So obviously, that's not going to work, if they want real-time data. So what was the solution, right? So the solution was on-the-fly transformations, right? And so that's kind of described, in the diagram that says high-level view of our Kafka-powered real-time transformation system. That diagram describes the new architecture that they used. So the key to the new architecture was message queuing, right? So what happened was they would dump the data from the production database into a message queue. The message queue would then get consumed, right, by the transformation logic, which is running in parallel, right, and insert the data into the database, right? And then they would have an API layer for all of their kind of, analytics that they did off of that database. They also pumped that data into Google's BigQuery. So they're using GCP, Google Cloud, and that's what they use for reporting, real-time reporting, right? So if by doing it this way, right, they did extract, load, and transform, right? Instead of ETL, they did ELT. So they loaded it into Kafka, and then they transformed it. And when they transformed it, they put it into 2 separate databases. One database was used by their API layer. The other database was used by the reporters, Okay, so separation of concerns, two separate end users, right? One end user is the customer. The second end user is the internal customer, the person in the company that needs to look at reports. Okay, so anyway, they just talks about it. They went from 36 hours to less than 8 minutes, you know. So that's a huge difference, right? Okay.
Right.
Yeah. So anyway, it talks about that. That article talks about that. So that article is available to you, you know, if you want to read more about it.
Let's start the Q&A session. We are going to have Q&A session for all of you. Do anyone have question? One of the question over here from Ming Xiang is about confidential computing. So Dr. Tarun, do you know anything about it? Maybe you can explain a little bit for Ming Xiang.
Yeah, so, you know, there's something that has just, you know, kind of become popular in recent days, right? Which is basically like, you know, I don't know what the exact term is now because it's been some months and years since I've heard that term. But it's something like homomorphic computing, where you can actually analyze encrypted data. And, you know, because I talked about this like many years ago. Actually, I gave a presentation on this, but I can't remember the term now anymore. But I guess the word doesn't matter, the concept does. So, you know, a lot of companies have been working for years on being able to process encrypted data.
Right. So
Right.
encrypted data could means our password or transactions, financial.
Well, no, the whole data set is encrypted, and despite the whole data set being encrypted, you can still do analytics on it. So that technology has, you know, actually become feasible now. So there are companies that are actually doing it. It's usually the large companies that are doing it, like Microsoft and Google. Yeah, so that's what it means, right? Confidential computing really means this type of whatever that term is, homeomorphic or whatever, where they're actually, you know, analyzing encrypted data.
Okay, right. So I think that answer your question, Ming Xiang. Let us know if you have any other questions. Anyone else have questions? Maybe Dr. Liana, if you are here, maybe you can type some questions for us, for Dr. Tarun to answer. Anyone else have questions regarding, you know, data management and all that? Okay, I have a question on behalf of the students. Dr. Tarun, can you share a little bit here and there about, since all of them are doing masters in data science, can you explain maybe like how could they advance their career after pursuing a masters in data science? And do you know what are the emerging jobs other than data scientists that, you know, is kind of like being everywhere? Everyone knows about data scientists, everyone knows about data analysts. Anything new in the market that you can share with them in terms of their career perspective?
I mean, there's a lot of jobs, you know, available. Actually, I do have another diagram, but I forgot to include it in the presentation. And that diagram actually, you know, showcases everything that we've talked about. It summarizes everything. But essentially, there's a number of roles that are growing, right, within big data management. So, of course, the biggest role is data engineer, right? The other role is data steward, also known as a data quality manager, right? And there's a bunch of other roles also that are emerging, you know, in recent years. And this is largely due to ML ops. ML ops stands for machine learning ops. Yeah. So there's a number of new roles that have emerged thanks to ML ops, right? And so one of the roles, right, has to do with monitoring model or concept drift. Model drift or concept drift means when you deploy a predictive model, a machine learning model in production, over time, its predictive power reduces, okay, as the environment changes, right? And there are people that are being hired just to manage that, you know? And so there's a number of new jobs being created. You know, there's also, of course, you know, data labeling. People are data labeler,
Right.
right?
How does it work?
Data labeler just means that, you know, let's say, for example, that you have a self-driving company, right? Self-driving car, right? And they want to improve their self-driving algorithm, right? Their machine learning model. So they need a lot of data that's already annotated or labeled. And so there are people that would actually, you know, provide that service. Yeah.
Okay. I think
Yeah. So there's a number of different jobs available now that didn't exist 5-10 years ago.
right. So I think we will see more new jobs opportunities with new terms. So I think all of you will be able to, you know, watch out in the job market and stay tuned to, you know,
Right.
CADS. We will
Yeah.
be able to.
There's also you know, data blockchain architects. That
Yeah.
job was created in the last 1 or 2 years.
Yeah, I believe so. So,
Yeah.
Dr. Liana asked, where can we start when we initialize a new big data project? How to get started?
So the first thing you need to do, right, is identify your data sources. Where am I going to get data from? Some of the data will come from second party, you know, companies, you know, outside of our company. Some of the data will come from inside our company, right? And so we need to organize it in a very neat, clean way, and also describe the schemas, right? And then we need to figure out what type of transformations we want to do on that data to make it useful. Okay? And after that, you build out your data pipelines to extract, load, and transform.
Right.
Yeah.
Okay. I think that's answer your question, Dr. Liana. Thank you, Dr. Tarun, for your session. For the next 10 minutes, I'm going to share with everyone on, you know, Dr. Liana questions actually. Any website can student refer to if they want to start learning big data? Yes, of course, we have it. Okay, let me share my screen. So Dr. Tarun is one of our instructor at the Center of Applied Data Science, and you are welcome to join our courses with Dr. Tarun, especially with Python. I've just attended one class with Dr. Tarun on Python analytics. Yeah, so let me share with you what we have for all of you. So thank you so much for staying up with us until now. And we are going to let you go very soon after I finish this presentation, and also to answer some of your questions regarding how can you be better. And I believe most of you are already much more ahead compared to a lot of the graduates out there, and also a lot of working professionals out there, because you have started learning, you know, taking masters in data science, and you are aware of the changes needed in the marketplace. And hence we have developed, CADS has developed Rubik, a platform to equip talents with data literacy skills, give you all the resources you need, and find you relevant jobs and projects opportunity. So you'll be able to go through our platform and to get, you know, improve your profile, get your career profile related to data science, related to AI, cloud computing, anything related to tech driven economy are here for you to explore. So in the platform, you'll be able to verify your skill competency. So anyone here already learned Python? If you already learned Python, you can come over and get tested on your skill on Rubik. If you are still new, I know one or two of you are actually from the bachelor degree. I'm not sure whether you are a technical person or not. If you want to learn totally new skills related to AI, related to data science, related to business analytics, big data, you are welcome to come over to the platform. Since all of you are here today, actually we have prepared a free gift for you. We are going to give you a free Big Data Analytics 101 course for you to get started to learn. And if you want to get more in-depth, like for example, changing your career to become a data analyst, changing your career to become a data engineer, we have the programs available for you. And you also can get certified. So let's say some of you are already, a business professional, or you have been working in IT, working in a computer science or information technology companies for a long time. You would like to refresh yourself and get certified with your existing skills. We do offer CADS verified skills as well, certification as well for you to take. Of course, jobs is one of the most important thing that we want to offer to the candidates. We are working with MNCs in Malaysia, public listed companies in Malaysia, to get the workforce upskill and reskill with regards to all the tech skills needed to future-proof the workforce. So in the system, if you were to go into Rubik, let me type out the link for you to go in right now. All of you can just click the link over here, www.thecads.com/Rubik. Go there and register for an account. You will be able to get your certification if you have existing, technical skills like Tableau. If you know how to use Hadoop, you'll be able to come and take an assessment. After taking the assessment, you'll be certified with CADS as long as you pass the assessment. Yeah, so you can also let us know, because we have hiring companies looking for talents like you, especially those you are going to finish your data science master's degree very, very soon. You'll be able to notify us by filling in your skills profile. Let us know you are a master's in data science candidate, and take our skill assessment. Let us know that you are familiar with Python, and you will be matched to our hiring organizations. So other than that, if you are just started out and you don't know where to start, you are unsure of what can you learn, and there are so many different technologies, different softwares that you need to start learning, which one to start first. We do offer you a learning path for you to get started as well. So based on the assessment of the technical skills, if you can, as you can see here, the technical skills here are here. You'll be able to, come in, take some assessment, let us verify your skills as well, and also get to know whether which one you want to further improve on. Yeah, so we have over 6,000 people already in the platform, participating in our platform to start learning and to get upskilled in data science and AI related programs. We are also working with like MBOT, Malaysia Boards of Technologies, to qualify or to verify your skills as a data professional. If you are not aware, basically MBOT offers TS qualification for any data related professional. So some of you already, in taking masters in data science, you can go to MBOT and apply for a TS title. It is something like board of engineer. Engineers have a board to monitor them and to register, right? So other than engineers, pharmacists, doctors, they have their own board to governing them. MBOT is one of the governing bodies in Malaysia to govern technicians, especially IT professionals and also data professionals. So we work very closely with them to get more people, especially data science qualifications people, to be registered with them, and we are also developing more future development programs to ensure that in Malaysia, we have enough data talents, enough analysts to work in important key industries and to move the country forward. Yeah. So in the future, we are also developing a customizable learning path for our Rubik users to use. Yeah. So just to share a little bit, these are some of our pathways, learning pathways for anyone who want to change their career. So if you don't have a master's in data science, you can come and explore some of our programs over here. We have You can become a basic data practitioner with basic data analytics qualifications, or you can become super technical to become like maybe a data scientist or data engineers to work with data. So it depends on your career path. We do have personalized learning path for you. Yeah. So in terms of our hiring companies, these are some of the hiring organizations that we are working with, and all the skills that you declare in the system, all the assessments that you are taking to recognize your skills are all matched to the companies looking for skill-based talents. So in the future, we know that maybe we are not going to work in the same job role forever and ever. You might be working with different teams, utilizing the same Python skills across different departments. So this is what we are moving towards in terms of the job and labor market. So we are working with over 300 organizations in both public and private sectors to get you the required skills and to get you the relevant jobs that will be able to benefit the nation and improve the economy. So currently, just now, Sheena already shared with you regarding the Data Star program for some of you to be able to apply. These are some of the companies that have already hired our Data Star candidates. And if you are keen to know more, go to www.cads.com/datastar to get to know more about DataStar graduate program. I would not be able to go in detail with you right now, but this is the website that you can go to. If you need any further clarification, just submit your inquiry in the website and we will be able to answer you accordingly. So all in all, what we do from the CADS is actually we have built a platform to help all of you in terms of getting in touch with individuals, with companies, with experts in the market to learn and improve yourself for data-driven, to work in a data-driven organization and to work in the future, future digital nation that Malaysia is currently building. And also you can build your personal brand over here by participating in our activities. We will be opening more activities for you to join in the future, and those who are more senior in profession will be inviting you to as a speaker or guest in our programs, so that you can share your knowledge and experience to get more people to know about data science and to know about what you are doing and how it can contribute to the workforce. So you can build a reputation with us and to gain verified certification from CADS, all in all to build a trusted personality that will for sure benefit you in the long term for your career advancement. Yeah. Other than that, we actually work with Swiss School of Management and to offer an MBA program in business analytics. There is an option for you to graduate in Rome upon successful, completion of the program. Okay, so we are also organizing a project or hackathon opportunity for all of you to participate, to work on projects or work in a competition offered by our hiring companies. So by participating in projects and hackathons, your profile in Rubik will be enhanced, and at the same time you can showcase your capabilities in terms of data analytics, in terms of AI to the world by working with us lah. So in the future, whenever there is any new projects coming in, any new programs offered, we are going to send you email and hope to see you in Rubik. So don't waste this opportunity. Why not all of you just take some time, go to the cads.com/Rubik. All you need to do is to create and complete your profile, take a skill quiz to assess your current skill level, and then you'll be able to unlock a certification feature. So if you have already learned database management, for example, or if you have already learned data storytelling, learned Tableau before, you'll be able to get additional certificate from CADS FOC for the first attempt. So other than that, you'll be matched to a personalized learning path lah, for you to get started to learn as well. Yeah. So if you have any question, do reach out to me. My name is Sukhani. If you want to know more about our programs, go to our website www.cads.ai, or the links that I've shared on top of this. So just ask me any question. We'll be able to answer to you very shortly, as soon as possible. So that's all for my presentation today. Anyone have any question regarding the program? Do you have any question? Okay, if you have no question, I think we will be able to finish the session right now. Yeah, so thank you for joining. You may leave now. Thank you. Thank you.